Hello Cloud Gurus, and welcome to this lecture on Azure SQL Access Control. There are two high-level components of all types of access control: authentication, which is the verification of an identity, and authorization, the determination of rights and permissions for a verified user. In the case of Azure SQL, authentication to the database or server can either be by SQL authentication or Azure AD authentication. Authorization for Azure SQL at the database level uses database roles and optional row-level security. We'll now look at each of these in more detail. So which is better from a security perspective, SQL authentication or Azure AD authentication? Let's take a look. Azure AD Identity Protection for risky sign-on alerts and Azure AD Password Protection to prevent the use of guessable passwords are only supported with Azure AD authentication. Similarly, conditional access and multi-factor authentication require Azure AD authentication. Azure AD authentication results in Azure AD auditing and logging, and there's a great advantage in Azure AD that users can have a single identity rather than many different user accounts, which can become unmanageable. And the ability to map database roles to Active Directory groups again requires Azure AD authentication. So from this table, you can see that there are many security advantages of using Azure AD authentication for Azure SQL Access Control. And I'd strongly recommend that you use Azure AD authentication rather than SQL authentication, wherever possible. When setting permissions assigned to a user within an Azure SQL database, it's important to apply the security principle of least privilege, i.e., only granting users access to the minimum permissions and data needed to perform their job function. Fixed database roles are the standard roles built into SQL Server, such as DB Owner and DB Data Reader. It's usual practice to assign these to administrator user groups. Roles generally shouldn't be assigned directly to users, as it can then become difficult to audit and manage access. Create user-defined database roles if needed. For applications accessing Azure SQL, the application service account should be assigned an application role with minimum permissions, or use the execute as statement to mitigate the risk of privilege escalation in the case of a vulnerability within the application. With row-level security, a user browses to a web app, which in turn connects to Azure SQL, where a database table has been configured with row-level security. This uses group membership or execution context to restrict access to specific rows within a database table. And now it's time for the Azure SQL Access Control Lab. Make sure you've already completed the SQL Network Security Lab. View the AZ-500 A-Cloud Guru GitHub repository. You'll find the link to this in the resources section for this lecture. Follow the detailed instructions within the SQL Access folder README. Enable Azure AD Admin on your Azure SQL Server. Connect from your Azure Virtual Machine using SQL Server Management Studio. And create a contained database user with an Azure AD identity and read-only rights. And then test. When you're finished, keep all the resources as you'll need them in the next Azure SQL Lab. If you'd like to take the challenge approach to this lab, please pause the video now, follow the instructions in the SQL Access folder within the GitHub repository, and when you're finished you can compare how you did it with my walkthrough. If you prefer the guided approach, then I'll see you in the Azure portal now. You've logged into the Azure portal. Begin by taking a look at the A-Cloud Guru AZ-500 GitHub repository. Go to the SQL Access section, where you'll find details of the prerequisites, requirements, detailed instructions, and some commands to copy and paste. Returning to the Azure portal, begin by browsing to the SQL Server. Select the Azure SQL Server you created in previous labs, and under the settings, go to Active Directory Admin. Currently you'll see that there's no Active Directory Administrator set up, so set an admin. This needs to be an Azure AD user. In my case, I'll choose the Global Admin user. And select. Then press Save. Your Active Directory Admin is being configured on your Azure SQL Server. Next, go to your virtual machines. Start your virtual machine if needed, and use the public IP address to connect via the Microsoft Remote Desktop client. You've logged into your Windows server using Remote Desktop. Start SQL Server Management Studio. Change the authentication type to Azure Active Directory Universal with MFA. For the username, enter your username for the Azure AD Active Directory SQL Server Admin and press Connect. You'll now be taken to the Azure AD login screen. Enter your password. You're now connected to Azure SQL with your Active Directory admin. Confirm that you can view the AdventureWorks database and also that you can see the master database as well. Right-click on the master database and select a new query. Copy the text in from the GitHub repository. Replace test user at your domain with one of your actual test users. In my case, I'll use ico at learnsecurity.cloud. Press the execute button and confirm that your Azure AD user appears under Databases, System Databases, Master, Security, Users. Here we can see that the Azure AD user has successfully been added as a user to the master database. Next, right-click on the AdventureWorks database, select New Query, paste in the query from the GitHub repository. In this case, we're adding a user and then adjusting the role to be DB Data Reader. As before, replace the test user at your domain with your actual username. In my case, that's ico at learnsecurity.cloud. Press the execute button. Confirm that your Azure AD users appears in AdventureWorks, Security, Users. Your Azure AD user is included as a contained user within the AdventureWorks database. Next, connect to the server in the context of your test user. Minimize the top button and press Connect, Database Engine. Leave the SQL Server name as before and the authentication as Azure Active Directory Universal with MFA. This time, replace the Active Directory admin user with your test user who has read-only privileges to the AdventureWorks database. Press Connect. Enter your test user's password. You're now connected in the context of your test user. To confirm that your test user has read-only access to the AdventureWorks database, expand databases, expand AdventureWorks, tables, and choose a table such as sales, LT, order details. Right-click and select the option to edit the top 200 rows. Try and change the sales order ID in the top row. And you should see an error that permission was denied on this particular object within the AdventureWorks database. And that's exactly to be expected, as your test user only had DB data reader role assigned. So that concludes the Azure SQL Access Control Lab. Keep the Azure SQL Server database and virtual machine for use in later labs, but don't forget to stop the virtual machine to minimize costs. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus, and welcome to this lecture on Azure SQL Data Protection. The three features which make up Azure SQL Data Protection are the encryption of data at rest, encryption of data in transit, and dynamic data masking. We'll now look at each of these in more detail. Beginning with encryption of Azure SQL data at rest. Transparent Data Encryption, or TDE, for Azure SQL adds a layer of security to help protect data at rest from unauthorized or offline access to raw files or backups. TDE doesn't protect data on the server when the database service is running, because at that point the key has been loaded into memory. In Azure SQL, TDE is enabled by default using an AES encryption key protected by a built-in service certificate. An alternative option is to use a customer-managed key protected by Azure Key Vault. Always encrypted, also known as encryption in use, is a feature designed to protect sensitive data stored in specific database columns, such as credit card numbers. In this case, data is always encrypted within SQL at an application level, and to read the data, a client accesses the encryption key to decrypt it. This key is never exposed to the SQL server. Rather, the key is held in the Windows Certificate Store of the application server, or Azure Key Vault. One of the advantages of using Always Encrypted is that database administrators, even if they have complete access to everything on the database, won't be able to decrypt that data unless they have access to the key. Azure SQL Server secures customer data in transit by encryption using Transport Layer Security, or TLS. A user opens a web browser which connects to an application server. This communication is encrypted using the app server's SSL certificate. The app server in turn connects to Azure SQL, with this data in transit being encrypted using the SQL Server SSL certificate. TLS encryption in Azure SQL is enabled by default. It's best practice to enforce encryption by specifying encrypt equals true in the database connection string, and also not to automatically trust the server certificate. This forces your application to verify the service certificate, ensuring the application is less susceptible to a man-in-the-middle attack. SQL database dynamic data masking limits sensitive data exposure by masking it to non-privileged users. Dynamic data masking automatically discovers potentially sensitive data in Azure SQL database and provides actionable recommendations to mask these fields with minimal impact on the application layer. It works by obfuscating the sensitive data in the results set of a query over designated database fields, while the actual data in the database remains unchanged. And now it's time for the Azure SQL Data Protection Lab. Make sure you've already completed the SQL Access Control Lab. Configure data masking of email addresses in the AdventureWorks database. Log in to your Windows virtual machine and open SQL Server Management Studio. Connect to the AdventureWorks database as the Azure AD admin. View the Sales LT Customer Database table and view the email addresses. Connect using the Azure AD test user from your SQL Access Control Lab, and then repeat, and now you should see the email addresses masked. And when you're finished, keep your SQL resources as you'll need them in the next Azure SQL Lab. If you'd like to take the challenge approach to this lab, please pause the video now, go ahead and complete these steps, and when you're finished you can compare how you did it with my walkthrough. If you prefer the guided approach, then I'll see you in the Azure portal now. You've logged into the Azure portal. Begin by going to your AdventureWorks SQL database, scroll down to Dynamic Data Masking. You'll see that SQL has already recommended various fields which could be sensitive and can be masked. Select the email address field and add a mask. SQL has already proposed a mask function, so press Save. You've successfully saved your dynamic data masking. Next, go to Virtual Machines. Make sure that your virtual machine is running. Grab the public IP address of your Windows virtual machine and connect using Microsoft Remote Desktop. Okay, you've connected to your Windows virtual machine using Microsoft Remote Desktop. Open SQL Server Management Studio. Once your SQL Server Management Studio has started, connect with your Azure AD admin user. In my case, that's the global admin user. Press Connect. Authenticate with your Azure AD credentials. Expand the Databases node and AdventureWorks, Tables. View the Sales LT Customer table by right-clicking and selecting the top 1000 rows. You'll see that the email addresses are all visible. This is exactly to be expected because dynamic data masking doesn't apply to administrator database users. So now, close the connection. Create a new connection, Database Engine. This time, authenticate with the test user which you created during the SQL Access Control Lab. Press Connect. Authenticate with your test user credentials. Close the existing window. And in the context of the test user, open up Databases, AdventureWorks, Tables. Right-click on the Sales LT Customer table and select the top 1000 rows. And you can see that the email addresses are all now masked. Well, that concludes the Azure SQL Data Protection Lab. Keep your SQL Server resources as you'll be needing these for the next SQL Lab. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello, Cloud Gurus! It's time to tidy up. Now that you're nearing the end of the course, you won't be needing your virtual machines anymore. To save cost, destroy your virtual machines, your network interfaces, and your disks. And that's it. You've tidied up for now. I'll see you in the next lecture. Hello Cloud Gurus and welcome to this lecture on Azure SQL Advanced Data Security. Azure SQL's Advanced Data Security offering includes three features: data discovery and classification, vulnerability assessment, and advanced threat protection. We'll now look at each of these areas in more detail. Beginning with SQL data discovery and classification, the Advanced Data Security feature of Azure SQL automatically discovers and classifies data held within the database. Having classified the data, it then labels the data within your database. These SQL information protection labels are uniform across your whole tenant and can be customized and managed within Azure Security Center, for which you need Azure AD Global Admin rights. The data classification labels are also included in Azure SQL Auditing as an extra tag, and this can be useful for monitoring and creating alerts. You can view visual dashboards of your data and classifications within the Azure portal, and also download the detailed results for further analysis. Azure SQL Vulnerability Assessment is another feature of SQL Advanced Data Security, which discovers, tracks, and helps you remediate potential database vulnerabilities. It should be used to proactively improve your database security. So, for example, in this screenshot, you can see that SQL Vulnerability Assessment has identified that database owners are not set up as expected, that database roles have been assigned directly to users rather than to groups, and that SQL auditing should be enabled at the server level. The vulnerability assessment results and detailed findings can be viewed from within SQL Advanced Data Security, and they also feed into Azure Security Center. The final feature of Azure SQL Advanced Data Security is SQL Advanced Threat Protection. Advanced Threat Protection detects anomalous activities, indicating unusual and potentially harmful attempts to access or exploit databases. Advanced Threat Protection can identify potential SQL injection attacks, access from an unusual location or data center, access from an unfamiliar principal or potentially harmful application, and brute force SQL credential attacks. And now it's time for the Azure SQL Data Discovery Lab. Make sure you've already completed the SQL Data Protection Lab. Ensure SQL Advanced Data Security is turned on. Enter your email address to receive alerts. View the vulnerability assessment for your AdventureWorks database. Configure SQL auditing and logging to send to your existing log analytics workspace. View data discovery and classification for your AdventureWorks database. Accept the recommendations, view the results, and save the configuration. And finally, view the tenant-wide SQL information protection labels within Security Center. When you're finished, destroy your Azure SQL server and databases, as you won't be needing them anymore. If you'd like to take the challenge approach to this lab, please pause the video now, go ahead and complete these steps, and when you're finished you can compare how you did it with my walkthrough. If you prefer the guided approach, then I'll see you in the Azure portal now. You've logged into the Azure portal. Go to your SQL server. Scroll down to Advanced Data Security and ensure that your Advanced Data Security is turned on. Enter your email address and save. Your Advanced Data Security settings are being updated to ensure that you receive email alerts. Now go to SQL Databases and go into your AdventureWorks database. At Advanced Data Security, Complete advanced data security setup by selecting a storage account for vulnerability assessment. Click on the link. Select a storage account in the East US region. Enter your email address to receive notifications. Ensure that Advanced Threat Protection Types is set to All and press Save. Your advanced data security settings are being updated. Return to your AdventureWorks database and initiate a new scan for your database. Press Scan, and a vulnerability assessment scan is being executed for your AdventureWorks database. The vulnerability assessment scan has now been completed. Some of the findings include the fact that auditing should be enabled at the server level. A minimal set of principals should be members of fixed Azure SQL DB master database roles, and that sensitive data columns should be classified. Next, you can remediate some of these findings. Go back to your SQL server, and at the server level, go to Auditing, turn Auditing on, and select your existing Log Analytics workspace in the East US region, and then save. You've now remediated one of the vulnerability assessment findings. Next, return to your SQL database, AdventureWorks, and under Advanced Data Security, you should now see Data Discovery and Classification alongside your vulnerability assessments. Click into the Data Discovery and Classification pane. You should receive a message that 15 columns have been found with classification recommendations. Click on the link, select all, and accept selected recommendations. Save your configuration. Return to your AdventureWorks database, where you should now see that the Data Discovery and Classification pie chart has been populated. You have confidential information and confidential information particular to GDPR, that's the European Union General Data Protection Regulation. You can view the tenant-wide security classification labels by going to Security Center, Resource Security Hygiene, Data and Storage, SQL Information Protection. There is a note here that you do require particular permissions to modify the information protection policy corresponding to Azure AD Global Admin privileges. Well, that concludes the Azure SQL Data Discovery Lab. There's one more thing to do, and that's tidy up. Go to your SQL server and delete. Enter the server name to confirm. Your SQL server, including your SQL database, is now being deleted. Well, that's the end of our Azure SQL Labs. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus, and welcome to this lecture on Azure Storage Security. Azure Storage is a Microsoft managed service providing cloud storage that is highly available, secure, resilient, and scalable. Azure Storage includes Azure Blobs. This is Microsoft's object storage solution for the cloud, optimized for storing large amounts of unstructured data such as images, videos, log files or backup data. Azure Files, which is a fully managed cross-platform file share in the cloud, accessible via the SMB protocol. Azure Queues, a service for storing and retrieving large numbers of messages. And Azure Table Storage, a service storing unstructured NoSQL data in the cloud, providing a key attribute store with a schemaless design. Having set the scene with the different types of Azure storage, this diagram shows an overview of Azure Storage Security. Azure Storage can potentially hold sensitive customer data. The best way to secure this is to use a defense-in-depth strategy. So if any one control is breached, another control is there to prevent an attacker from succeeding. The outermost layer is network security, where we control which IP addresses and networks are allowed to connect to the storage account. The next layer of security is access control, comprising authentication of the user or application accessing the storage account and authorization, defining permitted actions and scope. Then we have encryption of data, both at rest and in transit, and monitoring and audit to log access requests, maintain records of resource level changes to configuration or permissions, and visualize and alert on performance metrics. We'll be looking at monitoring and auditing as part of this lecture, and the other areas we'll cover in the next few lectures and labs. It's important to enable logging on Azure Storage so that there's a record of every access request. You should enable diagnostic logging and use version 2.0 so that logs of Azure AD authenticated access are included. Access logs are stored in the $logs container on the same storage account that is being accessed. This isn't ideal from a security perspective because if an attacker succeeds in compromising a storage account, they can delete or manipulate the logs. It's therefore best practice to copy the logs elsewhere in near real time. This could be to a Security Information and Event Management System, or SIEM, or to an Azure Log Analytics workspace. Azure Storage Analytics performs logging and provides metrics data for a storage account. You can use this data to trace requests, analyze usage trends, and diagnose issues with your storage account. Storage Analytics needs to be enabled individually for each service you want to monitor. You can either enable it programmatically or using the Azure portal. And Storage Analytics can be viewed in the portal at Azure Monitor Insights. And now it's time for the Azure Storage Security Lab. Begin by creating an Azure storage account in the East US region. Enable version 2 logging at diagnostic settings. Create a container with the access level blob. Upload an image. View the image from your web browser on your laptop. And then connect using Storage Explorer to view the logs. After that, add your new storage account to Storage Analytics. And when you're finished, keep your resources as you'll be needing them for the next Azure Storage Lab. If you'd like to take the challenge approach to this lab, please pause the video now. Go ahead and complete these steps, and when you're finished you can compare how you did it with my walkthrough. If you prefer the guided approach, then I'll see you in the Azure portal now. You've logged into the Azure portal. Begin by going to Storage Accounts, Add, select your existing resource group in the East US region. Give your storage account a unique name. Choose the East US region. Keep the account as standard. Review and create. Create the storage account. This may take a few minutes, so you may want to pause the video and press play once your storage account has been deployed. Your storage account has now been deployed, so go to the resource. At Diagnostic Settings, enable version 2 logging, read, write and delete. Keep the data retention at 7 days and save. The diagnostic settings have now been updated for your storage account. Next, go to Containers, create a container, give it a name such as Images, change the public access level to Blob, which is anonymous read access for blobs only, and press OK. Your storage container has now been created. Enter the container, select an image file and upload. Your image file has now been uploaded. Click on the link, copy the URL to the clipboard, open a new tab, paste and go to your image. You've now accessed the image from your web browser over the internet. You can refresh a couple of times to generate a few more logs. The next step is to connect using Storage Explorer. Your new storage account should be shown within Storage Explorer. Expand the node, expand blob containers, and you'll see that there's a $logs directory. At the current time, there are no access logs in the $logs folder, so I'd suggest coming back in around 10 minutes and trying again. Okay, well, you've returned after 10 minutes or so. Refresh the $logs folder, and you should now see some logs. Expand the blob, 2019, and the date, and then you'll see details of the actual logs here. You can, if you wish, download them and inspect them, which will then provide details of the access earlier from your web browser. Now return to the web browser, into your Azure portal, go to Monitor, Storage Accounts under Insights. Your storage account should be shown here. If it's not, then you can add it at this point. Selecting the storage account will provide details of transactions, latency, availability, and success of the transactions. Well, that's it for the Azure Storage Security Lab. Keep your storage account as you will be needing it in later labs. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus and welcome to this lecture on Storage Account Firewall. Azure storage accounts often contain customer confidential data such as scanned personal documents or database backups. Azure Storage is a platform as a service with a fully qualified domain name which resolves to an internet routable IP address. If your Azure storage account name is your storage account name, then the FQDN would be your storage account name .blob.core.windows.net. By default, an application server in Azure connects to a storage account via the internet. With this architecture, there's a significant risk of a data breach. An attacker can directly connect to the storage account via the internet in exactly the same way you viewed an uploaded image on your storage account from your browser in the previous lab. If a storage container is misconfigured as public when it should be private, data can be accessed anonymously. And even if a storage container is set to private, an attacker can still access it from the internet if they've obtained the credentials. When this approach is taken, there's no defense in depth. If your storage account is misconfigured, or credentials are lost or made public, then there's a high likelihood that your data will be breached. To mitigate this risk, you need to enable Azure Storage, Firewall and Virtual Networks. This allows a specific subnet within an Azure Virtual Network to connect to the Azure Storage account. When the subnet is allowed, it's also necessary to enable the Azure Storage Service endpoint on that subnet. This creates direct routes to the public IP addresses for Azure Storage within a given Azure region. That way our evil attacker can no longer connect, as there's a default deny rule in place. You may also have an administrator who needs to connect from a public IP address. That's fine. Just add specific IP addresses or network ranges to the Azure Storage Firewall. Azure Storage Firewall and Virtual Networks is a great example of the defense-in-depth security principle. We now have two controls in place: access control and network security. So even if a credential is lost or stolen, or the storage account is misconfigured, the data cannot be accessed from an unauthorized IP address or Azure network. And now it's time for the Storage Firewall Lab. Ensure you've already completed the Azure Storage Security Lab. Check you can view your image in the storage account from your web browser. In a new tab, go to your storage account in the Azure portal and then to Firewall and Virtual Networks. Change the selected settings to include your front-end subnet within your virtual network, which will enable the service endpoint. Add the authorized network to the firewall settings and save. Refresh your browser to view the image again from your laptop, and this should now fail. Back in Firewalls and Virtual Networks, add the client IP address of your laptop and save. Refresh your browser to view the image again, and this time it should succeed. If you'd like to take the challenge approach to this lab, please pause the video now, go ahead and complete these steps, and when you're finished you can compare how you did it with my walkthrough. If you prefer the guided approach, then I'll see you in the Azure portal now. You've logged into the Azure portal. Go to your storage account, then go to Containers, Images. The image which you uploaded you should now see. Copy the URL to the clipboard, open a new tab, paste and go to your image. You should now see the image you previously uploaded to the storage account from your web browser going over the internet. Next, return to the Azure portal. Within your storage account, go to Firewalls and Virtual Networks. By default, access from all networks is allowed, which is why you can view the image. Choose Selected Networks. Add an existing virtual network. Choose the virtual network in East US and the front-end subnet. Press Add and save. Your updated firewall and virtual network settings have now been saved. Return to your second tab, refresh the browser, and you should see an authorization failure. That's exactly to be expected because you've just put a firewall in place and you haven't allowed your own public IP address. Return to the Azure portal. Within Firewalls and Virtual Networks in your storage account, select the option to add your client IP address. Save. The Firewall and Virtual Network settings have now been updated. Return to your second tab, refresh, And you should now see the image again. Exactly as expected, because your public IP address is now included within the allowed addresses in the firewall and virtual network settings of your storage account. Well, that concludes the Storage Firewall Lab. Keep your resources as you will be needing them in later labs. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus and welcome to this lecture on Azure Storage Access Control. We'll begin by looking at Azure Blob container permissions. There are 3 permission levels to choose from for Blob containers. Private, where there is no anonymous access. Blob, which is anonymous read access for blobs only. That's what you used in the previous Azure storage labs. With this access level, there's anonymous read access to objects, such as images, but you can't get a directory listing of all objects within a container. And container. That's anonymous read access for both objects and containers. This allows an anonymous listing of all the objects within a container. The default access setting for a new container is private. When you create a new storage account, 2 access keys are generated, as you can see in this screenshot. These master level access keys give full read and write access to the entire storage account by adding the connection strings shown to the end of a request URI. From a security perspective, the existence of these keys represents a significant risk. If an access key is compromised, for example being accidentally pushed to GitHub, the entire contents of the storage account can be stolen, modified, or replaced. Access keys should be regularly rotated to reduce the risk of a storage access key being used maliciously. That's why there are 2 keys. Any client using the first key needs to be switched to the second, and then the first key can be rotated without it affecting applications or services. A shared access signature, sometimes referred to as a SAS token, is a URI that grants restricted access rights to Azure storage resources. You can provide a shared access signature to clients who shouldn't be trusted with your storage account key, but to whom you wish to delegate access to certain storage account resources. Shared access signatures are issued for a specific period of time. If they only apply to one type of service, they're referred to as a service SAS token. However, you can also create an account-level shared access signature. In this case, access is granted to multiple storage services, i.e. more than one out of blob, file, queue, or table. Stored access policies are a method of simplifying management by grouping together shared access signatures and providing an element of centralized control. Stored access policies are not supported for account-level shared access signatures. Here's an example of how to use a shared access signature to access a private storage resource. The main URI is https and then your storage account name, followed by .blob.core.windows.net, / and then your container name, and then another / followed by the object file name. To authorize access, that's followed by a SAS token, as shown in the example here. This is a very long string, as you can see, so let's break it down to examine each section in turn. The first element of a SAS token is SV, or the signed version. That's the version of the shared key authorization used, which must be one of the version numbers published by Microsoft. Then, in the case of an account-level SAS token, we have the SS for signed service, which can be any one of B for blob, F for files, Q for queues, or T for table. Next up is SRT for signed resource type, which can be S for service-level APIs, C for container, or O for object. SP means signed permissions, which can be any out of read, write, delete, list, add, create, update, or process. ST is the signed start date and time at which the SAS token becomes valid. and SE is the signed expiry date and time when the shared access signature is no longer valid. Best practice is to keep the SAS token lifetimes as short as possible to help reduce the risk of unauthorized use. SIP is an optional field which specifies an IP address or network which is allowed to connect. If this is omitted, then the token can be used from any IP address. SPR is the signed protocol, which is another optional field, and that can specify if the request is allowed to be both HTTP and HTTPS, or only HTTPS. And finally, the signature part of the URI is a signed hash of all the preceding fields, using the SHA-256 algorithm, and signed by one of the two storage account access keys. This is used to authorize the SAS token, and also to prevent anybody from trying to manipulate the string and change permissions. Management of SAS tokens can be a challenge. There's no easily accessible centralized list of issued tokens, and also no way to revoke a single token after it's been issued. That's why it's best practice to keep the lifetime as short as possible. Stored access policies are designed to alleviate some of these issues. A stored access policy groups shared access signatures together and allows you to change the start or expiry time, permissions, or revoke all the tokens associated with that policy. Key rotation of the main storage account access keys can be an issue. Rotating an access key immediately invalidates all the shared access signatures which that key has signed. So you need to issue new shared access signatures using the second key before rotating the first key. So I have a question for you. Do you think SAS tokens are a practical method of access control? If you like, you can let me and your fellow students know what you think in the lessons discussion room. Azure Active Directory Access can be used to access storage resources. Azure AD Access is supported for blobs and queues, and allows the use of a managed identity, for example if a virtual machine needs to access blobs in a storage account. RBAC roles are used for authorization. You can use built-in resource roles, for example storage blob data reader. You then assign the role to the user identity and define the scope, for example a specific storage account. I'd strongly recommend using Azure AD Access instead of shared access signatures or keys, wherever possible, as you get all the benefits of centralized management and auditing. While Azure AD Access is directly supported for Azure Blobs and Azure Queues, with Azure Files you can use Azure Active Directory Domain Services, or Azure ADDS. Azure ADDS is a service providing fully featured Active Directory domain controllers on Azure virtual machines inside your virtual network, managed and maintained by Microsoft. Once you've enabled Azure ADDS, it synchronizes users, groups, and hashed passwords, pulling these from Azure AD. You can then join your Azure virtual machines to the Azure ADDS domain and authenticate with Azure AD credentials. Azure ADDS returns a Kerberos token, and a logged-on user to the virtual machine can then access Azure Files in a storage account using their Azure AD credentials via the SMB, or Service Message Block, protocol. Let's take a look at the workflow for setting up Azure ADDS authentication for Azure Files. We'll split the steps into prerequisites in green and enablement tasks in purple. Firstly, select or create your Azure AD tenant. Check whether Azure Active Directory Domain Services has already been enabled, and if the answer is no, then enable Azure ADDS. Next, join your virtual machines to the Azure ADDS domain. Select or create Azure file shares, and then enable Azure Files Azure ADDS authentication on the relevant storage accounts. Assign share level permissions, and Configure directory or file level NTFS access control permissions for more granular control. And finally, mount the file share using your Azure AD credentials. We'll round up this lecture by bringing together all the different options for Azure Storage Access Control. There are 4 storage services: blobs, files, queues and tables. The only one of these which supports anonymous public read access is blob storage. That's what you used for the earlier Azure Storage Labs to view an image which you uploaded. The 2 storage account access keys give complete read and write access to all services. Shared access signatures can also be used to access all storage services, either using service-level SAS tokens, which just gives access to one of the services, or account-level SAS tokens for accessing more than one storage service. And finally, we have Azure AD access. At the time of recording this video, direct Azure AD authentication and authorization is supported for blobs and queues, but not tables. You can access Azure files using Azure AD credentials by authenticating to Azure Active Directory domain services. Well, that wraps up this lecture on Azure Storage Access Control. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus and welcome to the Storage Access Control Lab. Ensure you've already completed the Azure Storage Firewall Lab. Check you can still view the image in the storage account from your browser. If you're not able to, you may need to check your storage firewall settings. Next, change the container access control level to private and make sure that you now can't browse to the image. Create a shared access signature and use it to access the image by appending the SAS token to the image URI. Next, connect using Storage Explorer. Within Storage Explorer, create a stored access policy and then issue a new SAS token associated with that policy and use it to access the image. Once you're finished, keep your resources, as you'll be needing them in the next Azure Storage Lab. If you'd like to take the challenge approach to this lab, please pause the video now, go ahead and complete these steps, and when you're finished you can compare how you did it with my walkthrough. If you prefer the guided approach, then I'll see you in the Azure portal now. You've logged into the Azure portal. Go to your storage account, containers, images, select your image, copy the URL to the clipboard, open a new tab, paste and go to the image, and you should still be able to access the image. If you're not able to, it's possible that your IP address may have changed since you did the last lab, in which case you'll need to update the storage firewall. Return to the Azure portal, up to Containers, select your container, change the access level from blob to private. Press OK. And now, confirm that you can no longer access the image by refreshing your second tab. You should receive the message that the specified resource does not exist. Now you're going to generate a shared access signature and use it to access the image within the private blob container. Return to the Azure portal, copy the URL of the image, paste it into a text editor. In my case, I happen to be using Visual Studio Code. Now that you've pasted in the URL, return to the Azure portal. Within the Azure portal, in your storage account, go to Shared Access Signature. Create a shared access signature. In this case, it can be for blob, You only need to access the object itself, not the service or container. And you only need read permissions. You can leave the default start and expiry time, which is 8 hours, and leave the allowed IP addresses so that any IP address can connect. You can leave the allowed protocols at HTTPS only and use the first signing key. Then generate the SAS and connection string. Scroll down to access the SAS token. Copy it to the clipboard. Return to your text editor. Paste it immediately after the URL. Copy the entire string. Return to your browser. Open a third tab. Paste the URL followed by the shared access token into your browser and press enter. You have now successfully accessed the image using your shared access token. Whereas if you were to refresh the browser tab without the shared access token, access is completely denied. The next step is to use a stored access policy. Connect to your account using Microsoft Storage Explorer. Expand the details of your storage account. Expand blob containers. Select your container in which your image has been posted and select Manage Access Policies. Press Add. Keep the default settings, which are read-only, with an expiry time of 1 week, and press Save. Select Get Shared Access Signature. For the access policy, choose the policy that you've just created. Press Create. Copy the query string. Return to your text editor. Replace the old shared access signature with the new one, which is associated with the stored access policy. Copy the string. Return to your browser. Open a fourth tab. Paste in the new URI and press enter. And again, you've successfully accessed your image, this time with a shared access signature associated with a stored access policy. Well, that wraps up the Storage Access Control Lab. Keep your storage resources as you will be needing them in a later lab. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus and welcome to this lecture on Azure Storage Encryption. Azure Storage Encryption helps to protect the confidentiality of customer data through encryption of data in transit and encryption of data at rest. We'll now look at each of these in turn. Azure Storage secures customer data in transit by encryption with Transport Layer Security, or TLS. The user or machine identity connects to Azure Storage with TLS encryption using Microsoft's SSL certificate for Azure Storage. With Azure Storage, the default setting is to require secure transfer using TLS. It is possible to allow the use of HTTP as well as HTTPS, and there may be some circumstances where this is necessary. For example, if the storage account is used as a static website where HTTP is required. Encryption of Azure Storage data at rest is enabled by default using a Microsoft managed key. In this scenario, the same encryption key is used for multiple customers, and Microsoft manages rotation and backup of the key. Optionally, you can use a customer managed key. For example, if this is specified by regulatory requirements. In this case, the key is stored within Azure Key Vault, and the Microsoft Storage Account Service is given access to the key. Use of a customer managed key for Azure Storage supports encryption of blobs and files. And now it's time for the Storage Encryption Lab. Make sure you've already completed the Storage Access Control Lab. You'll also need the key vault which you created in the Disk Encryption Lab. Begin by logging into the Azure portal with the same Azure AD credentials you used for the Disk Encryption Lab. Create a 2048-bit RSA key in your Azure Key Vault in EastUS. In your storage account settings, Encryption, select Use Your Own Key. Choose the Key Vault and the key that you've just created. Note the warning that soft delete and purge protection will be enabled. And save. When you're finished, you can delete the storage account and key as you won't be needing them anymore. If you would like to take the challenge approach to this lab, please pause the video now. Go ahead and complete these steps, and when you're finished you can compare how you did it with my walkthrough. If you prefer the guided approach, then I'll see you in the Azure portal now. You've logged into the Azure portal. Begin by going to Key Vaults. Select your Key Vault in the EastUS region. Go to Keys. If you get a warning that the operation list is not enabled in this Key Vault's access policy, that just means that the identity which you're logged in as has not been authorized on Key Vault. In that case, go to Access Policies, add an access policy, configure from Templates, choose Key Secret and Certificate Management. Under Select Principal, search for your own identity. In my case, that's the global admin account. Select and add. Press Save. Your Key Vault access policies are being updated. Return to Keys. You should no longer see the error message. Create a new key. Give it a name, like storage key. Leave the key type as RSA and the key size as 2048. Press Create. Your storage encryption key has been created. Now return to your storage account. Select Encryption. Use your own key. Choose the Key Vault in EastUS and choose the storage key which you've just created and save. Note the warning that soft delete and purge protection will be enabled on the Key Vault. Your server-side encryption has now been updated to use a customer managed key. Well, that's the end of this short lab on storage encryption. You can go ahead and delete the storage account and key if you like, as you won't be needing these anymore. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus, and welcome to this lecture on HD Insight Security. Azure HD Insight is a big data analytics service. It uses open source frameworks from the Hadoop technology stack, and it's a managed cloud service, making it easy, fast, and cost-effective to process massive amounts of data. Supported open source analytics components include Apache Hadoop, the original open source framework for distributed processing and analysis of big data sets on clusters, Apache Spark, a parallel processing framework with in-memory processing to boost the performance of big data analytic applications, Kafka, an open source distributed streaming platform for real-time streaming data pipelines, Apache Hive, data warehouse software built on top of Hadoop for providing data query and analysis with an SQL-like interface, and Apache Storm for real-time processing of data streams. Here's an example HD Insight scenario for a large enterprise implementing a streaming big data solution encompassing connected cars, clickstream analysis and fraud detection. These streams of data feed into Azure Gateway Services and IoT hubs and are then routed to a dedicated virtual network for the HD Insight cluster. Components include Kafka for data streaming, Storm for real-time processing and Spark for parallel processing. The output from HD Insight is fed into long-term data storage, real-time applications and real-time dashboards. This approach can be used to analyze billions of events being streamed every day from millions of connected devices. As with all Platform as a Service or PaaS services, there are a range of controls which can be grouped together in a layered approach in line with the Defense in Depth security principle. Perimeter security in HD Insight is achieved through virtual networks. An HD Insight cluster can be created inside a virtual network, and then you can use network security groups to restrict access. The Enterprise Security package from HD Insight provides Active Directory-based authentication, multi-user support and role-based access control. The Active Directory integration is achieved through the use of Azure Active Directory domain services. With these capabilities, you can create an HD Insight cluster that's joined to a managed Active Directory domain, and then you can configure a group of individuals from the enterprise who are allowed to authenticate and sign into the cluster. As Azure AD-DS synchronizes identities from Azure AD, that means Azure AD credentials can be used to access HD Insight. Authorization to HD Insight is at two levels. At the Azure resource level, there are built-in RBAC roles, the HD Insight Cluster Operator role and the HD Insight Domain Services Contributor role for management of the Enterprise Security package. At a deeper level, authorization to specific resources within HD Insight is achieved using another Enterprise Security package feature, Apache Ranger role-based access control. This ensures people only have the permissions within HD Insight needed to perform their job function. For example, the administrator can configure Apache Ranger to set access control policies for Hive with column-level data masking to filter sensitive data from unauthorized users. Auditing of HD Insight is provided by Azure Monitor and comprises Apache Ranger and Ambari audit logs, as well as SSH access logs. Encryption of data within HD Insight is important for meeting organizational security and compliance requirements. The data stores used by an HD Insight cluster are Azure Blob Storage and Data Lake. Both of these support encryption of data at rest and in transit. Compliance aspects for HD Insight may be important for your organization. To ensure appropriate certifications, validations and assessments are in place to meet any regulatory requirements for particular industry sectors. Compliance dashboard reports against frameworks such as PCI DSS and ISO 27001 can be viewed within Azure Security Center. Microsoft Trust Center includes Compliance Manager, a Microsoft solution helping organizations to meet compliance obligations with ongoing risk assessments, insights, and a simplified compliance process. The HD Insight Enterprise Security package can be used to put in place Active Directory authentication with role-based access control and multi-user support. The HD Insight cluster is created in the same virtual network as Azure Active Directory Domain Services, which provides Microsoft-managed domain controllers in the cloud. Azure AD-DS synchronizes groups, users, and hashed passwords from Azure AD. And the HD Insight cluster nodes are joined to the Azure AD-DS domain, allowing the use of Kerberos tokens for authentication. To set up an HD Insight cluster with the Enterprise Security package, a managed identity is created and assigned to HD Insight with the HD Insight Domain Services Contributor role. Well, that wraps up this lecture on HD Insight Security. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus and welcome to this lecture on Cosmos DB Security. Azure Cosmos DB is Microsoft's globally distributed cloud database, supporting multiple database APIs and using the NoSQL model for datasets, with no requirement for database schemas or index management. Cosmos DB supports global distribution across Azure regions. It's a global database, though can be implemented in a single region if desired. It's always on with 99.999% availability, that's 5 nines, and guaranteed throughput. Cosmos DB has very low read and write latency, and 5 consistency models to choose from, with elastic scalability. Cosmos DB database APIs include MongoDB, Cassandra, the Graph or Gremlin API, SQL, and the Table API for applications originally written for Azure Table Storage and needing some of the additional capabilities of Cosmos DB. Like other Platform as a Service or PaaS services, security controls can be grouped together and multiple controls should be implemented to achieve defense-in-depth security. Network security for Cosmos DB can be configured using the Cosmos DB Firewall and Virtual Networks feature. This is exactly equivalent to Azure SQL and Azure Storage Firewall and Virtual Networks, and it's an important control which can prevent attackers directly connecting to your Cosmos DB over the public internet. There are some occasions where you won't be able to do this, for example if you're using a mobile app to directly connect to Cosmos DB. Cosmos DB automatically encrypts data at rest by default using a Microsoft managed key, and there's the option for Transport Layer Security or TLS encryption of data in transit. Authorization to Cosmos DB at the data level can be achieved using either access keys or resource tokens. We'll go into more detail on both of these in a moment. Cosmos DB provides audit logs which, as with other Azure diagnostic settings, can be streamed into a log analytics workspace, an event hub or Azure storage. And at the Azure resource level, Azure Activity Log will record changes to the Cosmos DB configuration and settings. When you create a Cosmos DB, 2 master read-write keys are automatically generated. These are conceptually similar to the 2 access keys for each Azure storage account and have complete read-write access to all Cosmos DB data. There's a primary key and a secondary key. Read-only keys are also available. Cosmos DB master keys should be rotated regularly to reduce the risk of misuse of a key which may have been stolen or accidentally made public. As with storage access keys, clients can be moved to use the second key and then the first key can be rotated, and this sequence of events avoids application downtime. How would you grant access to Cosmos DB from an untrusted application or device, such as a mobile app? You could package the master key into the application, which could then connect directly to Cosmos DB. While that would work, it's a very high risk. The application could be decompiled or the traffic intercepted and the master key obtained, and then misused. From an availability perspective, it's not a good idea either, as the application will stop working if the master key is rotated. So we're not going to take this approach. Instead, build a mid-tier service, most likely on an Azure virtual machine, and give it the Cosmos DB master key. The user of the mobile app authenticates to the mid-tier service, which then requests permissions from Cosmos DB, which generates a resource token and passes it to the mid-tier service, which then sends it back to the mobile app. A Cosmos DB resource token is conceptually similar to a SAS token for a storage account, with limited resource access and permissions. Once this is returned to the mobile app, the user can now connect directly to Cosmos DB, but only with the permissions associated with the resource token and only for the specified amount of time. Using Cosmos DB resource tokens provides time-bound permissions to specific Cosmos DB items. And now it's time for the Cosmos DB lab. Make sure you've already completed the Log Analytics lab, as you'll be using a Log Analytics workspace. Download or clone the AZ-500 A Cloud Guru GitHub repository to your laptop. You'll find the link to this in the resources section for this lecture. Follow the detailed instructions in the Cosmos DB folder README. Create a Cosmos DB account. Create a Cosmos DB database. Query the database, and then view Cosmos DB insights and logs. When you're finished, destroy the Cosmos DB account. If you'd like to take the challenge approach to this lab, please pause the video now, go ahead and follow the instructions in the GitHub repository, and when you're finished, you can compare how you did it with my walkthrough. If you prefer the guided approach, then I'll see you in the Azure portal now. You've logged into the Azure portal. Go to Cosmos DB. Create an Azure Cosmos DB account. Create a new resource group. Enter a globally unique account name. Leave the API as core SQL. Change the location to East US. And leave the geo-redundancy and multi-region rights as disabled. Select Next Networking. Choose your existing virtual network in East US. Choose your front-end subnet. This will enable the Microsoft Azure Cosmos DB service endpoint. Allow access from the Azure portal, and also allow access from your own IP address. Review and create. And create. Your Cosmos DB account is being deployed. Creating the Azure Cosmos DB account may take 10 minutes or so, so I'll fast forward the video now, and you might want to pause the video and press play again once your own deployment is complete. Okay, so after around 10 minutes, your deployment should now be complete. Go to the resource. Within your Cosmos DB settings, start by going to Diagnostic Settings. Add a diagnostic setting. Give it a name. Send to Log Analytics. Choose your existing Log Analytics workspace in East US and select everything. Press Save. Your diagnostic settings for your Cosmos DB account have now been updated. Now go to Data Explorer. Select New Container. Call your database Data. Your container ACG. Partition key should be instructor. The / is automatically added. Press OK. Your Cosmos DB database and container have now been created. Expand ACG. Select Items. Upload an item. and browse to the acg.json file, which is in the same folder as the README of the GitHub repository. If you haven't yet done so, you'll need to download or clone the A-Cloud Guru AZ-500 GitHub repository to your laptop at this point. Once you've navigated to the acg.json file, press open and then upload. The dataset has been uploaded and you should see 5 items created with no errors. Next, run a few SQL queries. Select ACG, select the 3 dots to the right of ACG and then New SQL Query. Begin with the standard query, select star from C. This will return all the results. And you'll see that the dataset is a very much reduced set of A-Cloud Guru courses. In fact, only 5 courses, just to show the principle. Next, there's a few more queries to run. These are detailed within the A-Cloud Guru repository under the Cosmos DB folder. That's the same folder where you've just uploaded the acg.json file. You can, if you wish, copy and paste some of the queries from here. So, for example, to return courses with a duration greater than 12 hours, select this query and execute query. The 2 courses which are longer than 12 hours are the AWS Certified Solutions Architect Associate course by Ryan Cronenberg and the AWS Certified Solutions Architect Professional by Scott Pletcher. The next query will return the names of the instructors in alphabetical order by first name. These are the instructors in this particular dataset. And finally, you can do a slightly more complex query. This query will return the course names for all courses where the cloud provider is Azure, and it will order them in alphabetical order. And these are the 2 Azure courses in this very small set of data. A-Cloud Guru does have many, many more Azure courses, AWS courses, and Google courses, and other courses, as well as the ones listed here. Having run some queries on the datasets, the next step is to view insights on the metrics associated with this Cosmos DB. Go to Azure Monitor, select Cosmos DB under Insights, click on the link for your Cosmos DB account. You should see information on your requests, namely your SQL queries, as well as billing information. If your requests don't come up immediately, you may want to come back in around 10 minutes and have another look then. So this provides metrics information. To view logs, select Logs, choose Query Editor, paste in this query from the GitHub repository or just type it in. We're looking for a string of ACG because that's the name of the collection in which our data resides. Press Run. You'll now see all the information on the SQL queries which you've generated in the Data Explorer section within the Azure portal. You can see that the category is Data Plane Requests. The resource ID will be under the database named Data, Collections, ACG, and then Docs. The status code should be 200 as the requests were returned successfully. Information is provided on your browser and your client IP address. You'll also see the region of the Azure resource, which is East US. So that's the end of this Cosmos DB lab. There's one more thing to do, and that's tidy up. Return to Cosmos DB, delete the account, and confirm the account name when prompted. Your Cosmos DB account is now being deleted. And that's it for this Cosmos DB lab. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus and welcome to this lecture on Data Lake Security. Azure Data Lake is a suite of managed cloud services allowing data scientists and analysts to store data of any size and format and perform fast processing and analytics using a variety of platforms and languages. Azure Data Lake solutions include HD Insight, a fully managed cloud service providing clusters using the open source Apache Hadoop framework, Data Lake Analytics, which is a cloud service where you can easily run massively parallel data transformations and processing programs using a range of coding languages over petabytes of data. Data Lake Storage is a secure, massively scalable data store built to the Open Hadoop file system standard. In this lecture, we'll be looking at the security of Data Lake Analytics and Data Lake Storage. HD Insight security is covered in a separate lecture on this course. Data Lake Storage Gen 2 is a set of capabilities dedicated to big data analytics and built on Azure Blob Storage. It implements a hierarchical namespace which organizes objects and files into a hierarchy of directories for efficient data access and massively speeds up data operations. A key feature of Data Lake Storage Gen 2 is Hadoop compatible access, allowing you to manage and access data in exactly the same way as a Hadoop distributed file system. Drivers are available, allowing HD Insight and other Azure Analytics services to straightforwardly query data held within Data Lake Storage. Access control for Data Lake Storage Gen 2 begins with Azure AD and role-based access control to the container level within the underlying storage account. For fine-grained access control, use access control lists in POSIX permission format on files and directories. Settings may be configured through Storage Explorer or using frameworks like Hive and Spark. Data Lake may well contain commercially sensitive or personal data which needs to be well protected. As with all Platform as a Service or PaaS services, Data Lake has a range of controls which can be grouped together in a layered approach in line with the Defense in Depth security principle. Network security for Data Lake is achieved through the firewall and virtual network settings of the underlying storage account. You'll already be familiar with this feature from the previous lecture and lab in the storage account section of this course. There are a range of options for access control within Data Lake. Azure AD authentication with role-based access control can be implemented at the container level, and there's also the option to use a shared key or shared access signature for the storage account. Again, you covered these topics in an earlier lecture and lab. The extra feature of Data Lake is the option of POSIX-style access control lists on files and directories within the hierarchical namespace built on top of Azure Blob Storage. Encryption of data in Data Lake uses the underlying storage account encryption of data at rest and in transit. And similarly, monitoring and audit uses storage analytics and storage logs. You'll remember the labs on encryption, monitoring and audit from the storage account section of this course. Azure Data Lake Analytics is an on-demand big data analytics service, allowing you to write queries to transform your data and extract valuable insights. The user queries Data Lake Analytics, which then analyzes data in the specified Azure data stores, including Data Lake, Azure SQL, Azure SQL Managed Instance, and Azure Storage. From a security perspective, Data Lake Analytics queries are run either in the context of an Azure AD user or in an automated manner using a service principal. In either case, the service principal or Azure AD user needs to use Azure AD authentication, with authorization provided at the resource level through built-in RBAC roles, and at the job folder level, the job folders describing particular data lake analytics queries. Authentication is again through Azure AD and authorization using ACLs. Moving on to data sources that can be configured and used by data lake analytics. In the case of Azure Data Lake, Azure AD authentication is supported with authorization at a fine-grained level through the use of POSIX ACLs. If Azure SQL is chosen as a data source for data lake analytics, Azure AD authentication needs to be enabled and then contained database users assigned specific database roles. Azure SQL Managed Instance supports Azure AD authentication through the use of Azure ADDS, that's Azure Active Directory Domain Services, and again, specific database roles can be assigned for the user in whose context the data lake analytics queries are being run. And finally, Azure Storage supports Azure AD authentication. However, authorization is only up to the container level using built-in RBAC roles. Well, that wraps up this lecture on data lake security. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello, Cloud Gurus, and welcome to this overview on application security. A large proportion of cyber attacks take place at the application layer, so it's important to be aware of the approaches which should be taken to develop secure applications. Application security is a huge topic which deserves a course of its own. However, it's not an area specific to Azure, and I don't expect this to feature much, if at all, in the exam. Hence, in this lecture, I'll provide an overview of different elements of application security without going into detail on each topic. If you want to learn more about app security from an Azure perspective, I'd recommend the Microsoft white paper Develop Secure Applications on Azure. You'll find the link to download this in the resources section for this lecture. The white paper goes through a standard software development lifecycle, beginning with requirements, moving on to the software design, the implementation, verification, release, and response. The paper highlights the need for a secure software development lifecycle. A good way to look at this is to take the steps highlighted earlier, requirements, design, implementation, verification, release and response, and then look at the different types of mitigations and controls which we can put in place at different stages of this lifecycle. Beginning with security requirements, it's important to set these up front, as with privacy requirements. A secure design review should be carried out during the design phase. Threat modeling is a great tool for understanding the threats and decomposing the application. Developer security training should be carried out on a regular basis and ideally within the particular languages that are used by the developers. Code reviews by peers or colleagues can be extremely helpful from a security perspective. Static code analysis is an automated technique to search through an entire code base, looking for patterns which indicate the potential for security vulnerabilities, such as SQL injection. Dynamic analysis looks at vulnerabilities within an application while it's actually running. Software decomposition analysis is another automated technique which scans through an application codebase and identifies third-party libraries and dependencies, and for each of these examines whether there are any vulnerabilities. A final security review is recommended before release, as is a penetration test by a third party to identify vulnerabilities and any security issues. Vulnerability management should continue on an ongoing basis after the software application has been released to production. And finally, it's really important that there's security involvement throughout the whole development process. One way of achieving this, if you're using an agile methodology to develop the application, is to appoint security champions to each developer team. Well, that concludes this overview of application security. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus and welcome to this lecture on App Service Security. Azure App Service enables you to build and host web apps, mobile backends and RESTful APIs in the programming language of your choice, with no infrastructure to manage, auto-scaling and high availability. Azure App Service enables automated deployments on Windows or Linux operating systems with a wide range of programming languages, including Microsoft.NET, Node.js or JavaScript, PHP, Python, Java, and HTML5. Microsoft provides recommendations on best practice security for App Service. You'll find the link to these in the resources section for this lecture. Beginning with authentication, App Service provides an OAuth 2 service for your identity provider. OAuth 2 focuses on client-developer simplicity while providing specific authorization flows for web applications, desktop applications and mobile phones. Azure AD uses OAuth 2 to enable you to authorize access to mobile and web applications. Moving on to authorization, it's important to restrict access based on role. You can use Role-Based Access Control or RBAC to assign permissions to users, groups and applications at a certain scope, such as the need to know and least privilege security principles. Protecting keys and secrets used within the application code is extremely important. Including a password or key within the code could potentially result in it being exposed in a public code repository such as GitHub, and then maliciously used by an attacker. Azure Key Vault helps safeguard cryptographic keys and secrets that are used by cloud applications and services. With Key Vault, you can encrypt keys and secrets, such as authentication keys, storage account keys, data encryption keys, PFX files and passwords, by using keys that are protected by hardware security modules. It's important to restrict network access, particularly if the app is only intended for private use within an enterprise. App service environments have a virtual network integration feature that helps you restrict incoming source IP addresses through network security groups. You should consider installing a web application firewall in front of your app service to help defend against exploits such as SQL injection attacks and cross-site scripting. Azure Web Application Firewall, or WAF, is a feature of Application Gateway that provides centralized protection of your web applications from common exploits and vulnerabilities. Azure Distributed Denial of Service, or DDoS protection, is a service which aims to block certain types of malicious attacks on your application while allowing through genuine user traffic. Finally, it's essential that you monitor your application and respond to performance and security issues. Application Insights monitors the availability, performance and usage of your application, while Azure Monitor logs can be used to view detailed application logs and create custom queries and alerts. By default, App Service uses HTTP or HTTPS with the standard App Service domain name. If you want to use HTTPS with your own custom domain name, you'll need an SSL certificate, for which there are several options. The App Service Managed certificate is free, or to be more accurate, included within the cost of App Service. It doesn't support wildcard or Apex domains. acloud.guru, without a www in front, is an example of an Apex domain, also sometimes referred to as a naked domain. The App Service Managed Certificate can't be exported. Another option is an App Service Certificate, issued by GoDaddy with integration through the Azure portal. This is chargeable and stored in Key Vault. And the third and final option is to bring your own certificate, optionally store it in Key Vault, and upload the PFX file to App Service. Configuration of SSL certificates in App Service is a three-step process. Begin by adding the custom domain. Then add a Transport Layer Security or TLS binding. And finally, specify or upload the certificate. Use of SSL certificates in App Service requires the Basic, Standard, Premium or Isolated App Service plan, all of which use dedicated compute resources. You can't use the free or shared pricing tiers, which run on compute resources shared with other customers. Azure Web Application Firewall uses an OWASP-based rule set to identify and protect against application-level attacks, including SQL injection and cross-site scripting, HTTP protocol-based attacks, and the use of bots, crawlers, and scanners. Azure WAF automatically updates its signatures on a regular basis and integrates with Application Gateway and Azure Front Door. Here's an example. A user of the application, deployed to App Service, connects via the internet with the HTTPS being terminated on an application gateway. An attacker can also connect over the internet and attempt an SQL injection attack. With Azure Web Application Firewall integrated to Application Gateway, the malicious traffic is identified and blocked, while the standard user can continue to work normally. Logs from the Web Application Firewall can be streamed to an Event Hub, Log Analytics workspace, or an Azure storage account. Azure WAF integrates with Security Center. If there's no WAF in place, Security Center will recommend its implementation. And once WAF has been enabled, alerts can be seen within Security Center. Azure DDoS protection, combined with application design best practices, provides defense against distributed denial of service attacks. Azure DDoS protection is offered in two service tiers, Basic and Standard. The Basic tier is free, whereas the Standard tier has a monthly charge and a usage element. There's no service level agreement or SLA in the Basic tier. However, an SLA is provided in the Standard tier. Metrics and alerts on DDoS attacks are available only for Standard tier, as are logging and reporting. The Standard tier enables access to the Microsoft DDoS response team, as well as service credits in the case of an app scale-out due to DDoS, which would normally incur additional costs for app service resources. Distributed denial of service or DDoS attacks are some of the most significant availability and security concerns facing customers moving their applications to the cloud. A DDoS attack attempts to exhaust an application's resources, making the application unavailable to legitimate users. DDoS attacks can be targeted at any endpoint that's publicly reachable through the internet. DDoS Protection Standard can mitigate several different types of attacks. Volumetric attacks, which aim to flood the network layer with a substantial amount of seemingly legitimate traffic, including UDP floods, amplification attacks, and other spoofed packet floods. Protocol attacks, which can render a target inaccessible by exploiting a weakness in the Layer 3 and Layer 4 protocol stack. Examples include SYN flood attacks, reflection attacks, and other protocol attacks. And application layer attacks, targeting web application packets to disrupt the transmission of data between hosts. Examples include HTTP protocol violations, SQL injection, cross-site scripting, and other Layer 7 attacks. The application layer functionality of Azure DDoS protection is provided through its integration with Azure Web Application Firewall. Well, that concludes this lecture on App Service Security. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus and welcome to the App Service Security Lab. You will require a registered domain to complete this lab, along with access to be able to create a DNS record. Start by viewing the AZ-500 A Cloud Guru GitHub repository. You'll find the link to this in the resources section for this lecture. Follow the detailed instructions in the App Security folder README. Create an app service plan and web application. Add a custom domain. Create a free SSL certificate. Add the TLS SSL binding. And view the web app using your custom domain. When you're finished, tidy up by destroying the app service and deleting your DNS record. If you want to take the challenge approach to this lab, please pause the video now, go ahead and follow the steps in the GitHub repository, and when you're finished you can compare how you did it with my walkthrough. If you prefer the guided approach, then I'll see you in the Azure portal now. You've logged into the Azure portal. Start Cloud Shell. Make sure you're in the PowerShell option for Cloud Shell. Your PowerShell version of Cloud Shell has now started. Begin by changing directory, typing cd $home /cloud drive. Check if you have anything in there from previous labs. And if you don't already have the GitHub repository, then clone it now. You've cloned the AZ-500 GitHub repository to your cloud drive. cd into the repository and cd into the app-security folder. Then run the PowerShell script app-security.ps1. The PowerShell script is creating an app service plan in the basic tier and a web application. Your app service plan and web application are being deployed. This may take 5 minutes or so I'll fast forward the video now. You might want to pause the video and press play again once your own deployment is complete. Okay, so your web application has been deployed to the East US region with a basic tier app service plan. The code for the web application is from this GitHub repository, also in the A Cloud Guru resources organization, with the title course AZ-500 web app. In the Azure portal, go to your app services. You'll see your new web app created here. Select the link. Copy the URL to the clipboard. Open a new tab. Paste in the URL. Keep being awesome, Cloud Gurus. Take a look at the certificate. You'll see that it's a wildcard certificate star.azurewebsites.net managed by Microsoft. In the real world, you'd want to use your own custom domain rather than a prefix followed by .azurewebsites.net. Go to your DNS management portal for your own registered domain. In my case, I'm using AWS and my registered name is learnsecurity.cloud. Create a new record set. Give it a name. In my case, I'll use web app. The type should be CNAME. And the value is the domain name from the URL, which you should still have within your clipboard. So simply go to the front of the URL, get rid of the https:// and create. Your CNAME has now been created. In my case, it's webapp.learnsecurity.cloud. Return to the Azure portal. Within your app service, select Custom Domains. Select the HTTPS only option. Add a custom domain. Enter the CNAME that you have just created. In my case, that's webapp.learnsecurity.cloud. And validate. Your custom domain has now been validated. Press the Add Custom Domain button. Your custom domain has now been added to the app service. Next, go to TLS SSL settings. Select Private Key Certificates. Create an App Service Managed certificate. The domain name is pre-populated with your CNAME, in my case webapp.learnsecurity.cloud, and create. Your App Service Managed certificate is being created, and your App Service Managed certificate has now been issued. Return to Custom Domains. Under your custom domain, add binding. Choose the certificate which you've just created, and under TLS SSL type, you should only have one option, SNI SSL. Press the Add Binding button. Your TLS SSL binding has now been created. Next, open a new tab and browse to HTTPS webapp, in my case, .learnsecurity.cloud. In your case, just go to HTTPS followed by your CNAME. Keep being awesome, Cloud Gurus. Check out the certificate, which you'll see has been issued to the exact domain, in my case, webapp.learnsecurity.cloud. Well, that's it for the App Security Lab. There's one more thing that you need to do, and that's tidy up. Return to the app service, go to the overview screen, and delete. Enter the name of your app service to confirm deletion. And to tidy up, delete your custom domain as well. Your domain name record will now have been deleted. You've now finished the tidying up. So, if you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello, Cloud Gurus. It's time to tidy up. You've finished all the labs on this course. Destroy everything. And set Security Center to free tier. Keep being awesome, Cloud Gurus. I'll see you in the next lecture. Hello, Cloud Gurus, and welcome to Secure Data and Applications Exam Questions. Here are two AZ-500 example exam questions. The skills measured are Secure Data and Applications, the fourth and final topic area of the AZ-500 exam blueprint. You have 6 minutes in total. Have pen and paper ready. The second question asks you to drag and drop, so note down the answer instead. Here's the first practice exam question. You have 3 minutes. Please pause the video now, and once you've noted down the answer, press play to see how you got on. Okay, well, how did you find that? A shared access signature has become compromised. How can access using it be prevented? Select all that apply. Let's just go down them one by one. A is use Azure PowerShell to list shared access signatures and revoke the compromised one. Well, that's just simply not possible. You can't list shared access signatures and you can't revoke a single shared access signature. So A is incorrect. B. Rotate the access key which was used to sign the shared access signature. Well, if the access key is rotated, the shared access signature is no longer valid. So access using that will indeed have been prevented, so that is correct. C. Remove the stored access policy which the shared access signature is linked to. That will prevent access from the shared access signature along with any other shared access signatures associated with that particular stored access policy. So C is also correct. And D. Access from a shared access signature cannot be prevented after it is issued. Well, that's clearly incorrect because we've already come up with two ways of doing it, B and C. So D is wrong. So the correct answer is B and C. Here's your second practice exam question. Allow yourself 3 minutes. Please pause the video now, and once you've noted down the answer, press play to see how you got on. Alright, well, how did you find that? The question is, drag and drop the tiles below in order to show the steps to assign an Azure SQL database reader role to an Azure AD user. Only include those steps which are needed. More than one order may be correct. Okay, well, the first thing that you have to do is to enable Active Directory Admin in Azure SQL. Then log in as the admin Azure AD user within SQL Server Management Studio. Next, create the contained database user. And finally, assign the DB data reader role. There's a couple of distractors in the list on the left-hand side. Logging in as the SQL admin user would not allow you to assign Azure AD users. And the last one on the list on the left, assign a SQL DB reader RBAC role. Well, a SQL DB reader RBAC role doesn't exist. So that's the end of these two practice exam questions on secure data and applications. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture.